Hey everybody, welcome back. In this very short lesson, we want to answer a basic question. What is radiation? Here's a good textbook definition. Radiation is energy in the form of waves, like photons, or particles emitted from a source and transmitted through space. So that's it. That's all radiation is, which obviously is a big, broad definition that includes a lot of things. So let's talk about the photons or the waves. The entire electromagnetic spectrum is radiation. So you don't always think of some of these things as radiation, like visible light or ultraviolet light or microwaves or radio waves, but technically all of those are forms of radiation. They're photons or waves that carry energy through space. And then of course we also have X-rays and gamma rays. If you'll notice on this spectrum, it's all photons. It's all wave radiation. The thing that changes through the spectrum is the wavelength. The wavelength of these photons changes, and that's the major difference between each area on the spectrum. Truly, a gamma ray is identical to visible light, identical to radio waves, but the thing that's different is that the wavelength has changed, and so the way that they interact in tissue and matter can be completely different. One obvious example is the difference between visible light and X-rays. X-rays can easily penetrate through the human body, but visible light doesn't. Visible light will be completely absorbed on the surface of the body. The main thing to understand, though, is that this entire electromagnetic spectrum is all radiation. It's all forms of radiation, and they're all types of waves or photons. The other big category is particle radiation, and this might be a type of radiation that you're less familiar with. It's actually particles. It's not just a package of energy. It's not just a wave. It's actual physical particles that have a mass. You can measure them. But just like photons, they're radiation, which means these particles can be emitted from a source and transmit through space. A few very common examples of particulate radiation include alpha particles, which you can see is actually 4 particles in one. Also beta particles or beta radiation, which is really similar to electrons. Also protons, neutrons, and electrons themselves. All of our subatomic particles can be emitted from an atom and transmitted through space, carrying energy, which then can be deposited into a material. So those are all forms of radiation, whether it's photons or waves compared to these particles, all forms of radiation. Here's a quick practice question to make sure you understand some of these concepts. What is the difference between a light photon and an X-ray photon? We talked about this one directly, but take a second on your own to try to write out the correct answer. All right, hopefully you did that on your own. So first we should talk about what's similar. Both light and X-ray photons are forms of radiation on the electromagnetic spectrum. So they are waves. They're wave forms or photon forms of radiation. The main thing that's different, though, is the penetrating ability of this radiation because of the wavelength. So they have different wavelengths, so they carry different amounts of energy, and they interact in the body in different ways. So that's a quick review on what radiation is. Please let me know if you have any questions. Thanks.